Have you ever pondered what happens when a colossal explosion occurs the vastness of space? The cosmos, home to some of the most powerful events known to science, plays host to space explosions, cataclysmic events far stronger than any earthly firecrackers. Our journey today will take us deep into the celestial phenomena, examining their existence, importance, and the awe-inspiring energy they unleash. Focusing on two main types of explosions, we'll explore both the large-scale cosmic events and the more localized satellite explosions. The first cosmic explosions can be detected from billions of light years away. They include supernovae, the spectacular death throes of giant stars, and gamma-ray bursts, the universe's most energetic events. These cosmic fireworks play a crucial role in the universe's life cycle, providing the elements necessary for the formation of stars, planets, and even life. The second, satellite explosions, while not as universe-shaking as supernovae or gamma-ray bursts, can still have significant impacts, disrupting communication networks and scattering debris in Earth's orbit. These man-made hazards pose unique challenges that we must navigate in our journey through the cosmos. Let's uncover the mysteries of these celestial explosions and deepen our understanding of our place within the cosmos. Because after all, we are all made of star stuff, born from the ashes of cosmic explosions. So let's begin our journey, a journey to the heart of the universe's most spectacular fireworks. Imagine an explosion so powerful that it outshines an entire galaxy, even if just for a moment. This isn't science fiction, it's the reality of supernovae and gamma-ray bursts, the universe's most energetic spectacles. Supernovae are the cataclysmic ends of massive stars, occurring when a star with a large mass collapses under its own gravity after exhausting its nuclear fuel. This results in a shock wave that forces the star's outer layers into space, releasing a vast amount of light, temporarily outshining an entire galaxy. Gamma-ray bursts are even more enigmatic and potent. They are the universe's most intense form of light, believed to be produced when a supermassive star collapses to form a black hole or neutron star, propelling jets of particles at almost light speed, generating a blast of gamma rays. These cosmic detonations aren't merely incredible light and energy displays. They also play a crucial role in the universe. Elements heavier than iron, such as gold and platinum, are created and dispersed across space in these extreme conditions. Furthermore, supernovae shock waves can instigate the formation of new stars and galaxies. These intense explosions aren't just destructive, they're creators, seeding the universe with the building blocks of new stars, planets, and possibly life. Just think about it, the gold in your ring, the iron in your blood, even the calcium in your bones. All these elements were once forged in the heart of a dying star or a powerful gamma-ray burst. These cosmic fireworks, while destructive, are crucial catalysts for creation in our universe. But not all explosions in space are natural phenomena. Consider this, the numerous satellites currently orbiting Earth, vital for our daily activities. Now, picture one of them exploding. Surprising, right? However, these human-made hazards happen more regularly than you'd expect. Satellite explosions can ensue due to various reasons. A mere glitch in the system can lead to catastrophic failure, or an accidental collision with another satellite or space debris can instigate a domino effect of calamity. So, what's the aftermath of a satellite explosion? The blast results in a flurry of debris scattering in all directions, consisting of hundreds or even thousands of smaller fragments, which persist in orbiting Earth at high speeds. Imagine bullets zipping around Earth at phenomenal speeds. That's what space debris resembles. This space debris constitutes a genuine threat to other satellites and space missions. It can harm or destroy functional satellites, causing disruptions in the services they render. Picture losing your GPS signal mid-journey or your weather prediction suddenly going blank. These are potential inconveniences we could encounter if excessive satellites get destroyed by space debris. Space debris can even endanger human life. Astronauts on the International Space Station endure the constant threat of space debris strikes. A tiny piece of debris can inflict substantial damage if it collides with the station at high speed. So, while star explosions millions of light years away may seem more fascinating, the explosions occurring right above us carry immediate, tangible consequences. They remind us of the risks tied to our reliance on technology and the significance of safeguarding our space resources. Satellite explosions, while less grandiose than cosmic fireworks, pose a very real and immediate threat to our modern way of life. Ever wondered what remains after these colossal explosions? Let's voyage to the remnants of these cosmic events, where supernovae births give rise to fascinating cosmic entities, neutron stars and black holes. First, we'll explore neutron stars, the condensed remnants of exploded massive stars. Although small in size, their density is exceptional. To grasp their density, consider this. A teaspoon of neutron star material would weigh 1 billion tons on Earth. These stars boast gravity second only to black holes. They have incredibly strong magnetic fields and rotate at speeds unimaginable, with some spinning 700 times per second. Next, we'll delve deeper to explore black holes. Formed from remnants of the largest stars, black holes are regions in space where gravity is so potent that nothing can escape, not even light. Yet they're not just cosmic predators. They play a critical role in the cosmos, influencing star formation and galaxy growth. They are essentially the cosmic architects. Both neutron and black holes are not only awe-inspiring in themselves, but also serve as extreme laboratories to test our understanding of physics. They present a unique lens into the universe's workings and continue to challenge our understanding of the cosmos. In the wake of destruction, new celestial bodies are born, continuing the cycle of the cosmos. So, what can we do to prevent man-made space explosions and their potential threats? The answer lies in robust engineering and diligent monitoring. Our satellites must be resilient, capable of withstanding extreme temperatures, radiation, and cosmic dust. Advanced systems can alert us to faults, allowing for timely intervention. Along with these, self-repairing technology can help fix minor issues autonomously. Our focus isn't just on the satellites, but also on their environment. We are working on cleaning up space debris that poses collision risks. Tools like nets, harpoons, and lasers are being developed for this purpose. Beyond prevention, we're focusing on future missions like Mars or traversing galaxies. We're researching advanced propulsion systems that are strong and safe, reducing explosion risks. Studies on alternative fuels like nuclear or ion propulsion are gaining pace. These fuels present a future where space travel is safer, faster, and more efficient. As we continue venturing into the cosmos, understanding and managing these explosions will be pivotal. Every step towards prevention and safety opens a new era in space exploration. Space, with its grandeur and mystery, is full of explosive events that shape the cosmos. We've explored supernovae, gamma-ray bursts, and man-made hazards. We've discovered neutron stars and black holes. Our exploration has just begun. Subscribe and hit the bell for more space content. Until next time, keep your curiosity ignited and never stop exploring the wonders of the universe.